Hello, math
enthusiasm.
First off, let me introduce my awesome teammates who've been working super hard alongside me. First, we have Bagas. Next is Matthew. And then there is Fahri. Yeah, that's me talking right now. And next after me is Son. And finally, we have Semeru. I just want to give a compliment to my teammates. Like, everyone here has been absolutely splendid in their work. So here, me and my friends would like to explain how to optimize inventory management for a sport equipment store known as Sehat Raga store. As we can see from the core problem, there is two core problems. High storage cost but fewer order, and lower storage cost but higher ordering costs.
Now let's take a look at the variables involved in this problem. The first one is annual demand. Sehat Raga sells 2,400 pairs of socks every year. This is the total number of units we need to manage in terms of ordering and storing. Number 2 is ordering cost per order. Each time an order is placed, the company incurs a fixed cost of 11,250 Indonesian rupiah. The third one is storage cost per pair per year, which is 600 Indonesian rupiah. And the last one, unit cost per pair of socks. Per pair of socks is 300 Indonesian rupiah. While this isn't directly used in calculating the economic order quantity, it might be relevant for analyzing the overall total cost.
Now, I'll be explaining about the core formula to solve the problem. So the core formula is actually, the main equation is total cost function. First, we need to know the details or parts of the equation. Q is actually order quantity, D is annual sales demand, S is ordering cost per order, C is cost per pair of socks, H is holding cost per pair per year. After we know all of those details, we make the part of the equation. Ordering cost is actually DS per Q, or annual sales demand times ordering cost per order divided by order quantity. And then there's a holding cost, which is actually holding cost per pair per year times order quantity divided by 2. So the main equation is actually DS per Q plus HQ plus 2, or ordering cost plus holding cost. Then there's also N equals to D per Q. N is actually the second problem that we need to solve, which is the number of order per year. And to solve that, the equation is annual sales demand divided by order quantity. And now to the calculation. The first thing that we need to do is to find the minimum cost. We take the derivative of TCQ with respect to Q and set it to 0. So basically, the derivative of total cost TC with respect to quantity Q equals to negative DS divided by Q to the power of 2 plus HQ divided by 2. After we find the equation, we set the derivative to 0 to find the critical point. So the main equation, negative ds per q to the power of 2 plus hq divided by 2 equals to 0. And then we move the ds per q to the power of 2 to the right to make it positive. And then we make the q to the power of 2 equals to 2ds divided by h. Because there's the q have the 2 to the power of 2, that means we have to make it gone, or to erase the 2, we make it a square root. So the q equals to square root of 2ds divided by h.
EOQ equals the square root of 2ds over h, which is 2 times 2,400 times 11,250 over 600 squared, which is 90,000 squared, which is 300 pairs. And for n, d over EOQ, which is 2,400 over 300, which is 8 orders per year. Verifying ordering cost, we get that from the integral of 1 times dsq dt. And number 2, holding cost. Assume a linear increase in inventory from 0 q over 2, then back to 0 over in a year, which is hq over 2. Combining these, we get tcq equals ds over q plus hq over 2.
So here's our final data. There are 6 parameter and 6 value that explains about the parameter. The first one is annual demand, which is 2,400 pairs of socks. Second is storage cost per pair per year, 600 rupiah. Fixed order cost, 11,250 rupiah per order. Cost per pair of socks, 300 rupiah. Optimal order quantity, 300 pairs of socks. Number of orders per year, 8 orders. Thank you for your attention.
See you next time.